Okay, for this next section, I'm gonna probably go through 27 through 39. I think is where it ends. Here we had to remember to take the keywords to write it as an equation or inequality. The keyword here on 27, it says for more than, okay, more than or more is showing addition, but more than, this is a switch around word, okay, and meaning we're going to switch the order, but it also says 3 times the number, okay, times, 3 times the number, or the times. So this is going to go to the front, and the addition is going to go at the back. The other keywords, anytime I see the word is, that is your equal sign, and then a number. So for anything of a number, I'm going to use the variable n. You can use x, you can use y, you can use anything you want. But 3 times the number, that means 3n needs to come first. Oh, let me rewrite that so you can see that. 3n plus 4 more, so add 4, is equals 175. So this is our setup. And then we're just solving for the variable x. So we have to isolate that, meaning doing the opposite of plus 4, so minus 4. And then that will end up giving us 3x is equal to 171. And so here, divide by 3x is going to equal 57. Okay. So on 28, we have now less than 2/3, 7 less than 2/3 of a number. So again, that then means we're going to switch these around. So 2/3 of a number would be 2/3 n minus 7 less than its subtraction is 5. So hopefully that's your setup. And then we're solving. This should come out to be a whole number. We do have some perimeter problems, and you have to kind of maybe draw a picture to help you. It says the perimeter is our distance around of a rectangle, is 24, and the length is 8. Find the dimensions of the rectangle. So like if I were drawing a rectangle, I know the length is 8, so opposite the sides here 8. What I'm missing is the width. And now I can combine like terms, which basically add up our sides to show perimeter, and that would be 2w plus 8 is 24, so equals 24. So there's your equation to help you solve that. The difference on 29 and 30 is now on 30 it says the length of the rectangle is 5 more than the width. If the perimeter is 42, what are the dimensions? When they're talking about the dimensions, they want to know what's the length and the width, the length by the width. So if we start off with, let me just change my font a little bit, of drawing a rectangle to help see the relationship. Since the length is 5 more than the width, so our length is, okay, 5 more than the width. So that would be whatever the width is plus 5. So we have a width, and our length is 5 more than that. So the width plus 5. And hopefully this will help you set up your combining your like terms to write your equation. If you add up your sides and make it equal to 42, that would be your equation. So I kind of got you started on that. I want to see if you can finish that. On 33, they gave you the sides lengths, okay? The sides of the triangle length of x. And the triangle has 3 sides, x plus 2 and 2x minus 40. That perimeter is 70. So if you combine the like terms, that gives you a total of 4 x's. Then a positive 2 minus 40 is going to leave you with negative 38. And that's going to equal to 70. And now you got your equation. Most people had questions about 32. It said Bob sold 2 times as many boxes of candy as Jim. Together, that's important, they sold 99 boxes. So I don't know what Jim sold. So I'm going to make Jim X. But I said Bob. I know Bill, sorry, did 2 times of that. Sorry about the font. So 2 times of that would be 2x. Together, they sold 99 boxes. So my equation here would be x, Jim plus Bill plus 2x equals 99. And now you can solve that one. So that takes care of your word problems. I'm sorry, that was supposed to be a bill. It doesn't look like bill. The next section gets into functions. Okay. A couple things you need to remember. F of x, this is function notation. It means the same thing. F of x equals y. Okay. Um, it's the same thing here. Your x is your input. Sorry, my font is bad. And your y is your output. Um, so input is what we're plugging in. Output is the result. So on 33, they give you the function of x is x squared plus 9, and the f of x, excuse me. And I want you to find f of 3. So you have to remember that what's inside the parentheses, just like here, x is inside the parentheses over here, f of x, that represents x. So basically this is saying x equals 3. When I see f of 3, that means that x is the value of 3. So when I plug this in, and anytime we see a number inside the parentheses in function notation, we have to use parentheses to show putting the input in, plugging it in, and solving. So parentheses squared plus 9, and what we're plugging in is that value of x, which was the 3 right here. So we're plugging in that 3 in the parentheses, and this following order of operations. So hopefully you see that 3 squared is 9. Then we're going to do plus 9. So our answer is 18. So remember our function notation, when we have fx equals y, it means y. Our answer can be an order pair of x comma y, or you can think of it as x comma f of x. So if I was to show, oops, that's an f of x, sorry. This would be the x is 3, the f of x or the y, the output is 18. Okay, so f of 3 equals 18. And there's your order pair, just to kind of recap. So we're going to have you plug it in and solve and work forward. Then we're going to ask you to read it off of a graph and a table. Remember your x here, that's your input. I'm just going to put an I for input. F of x is the same thing as your y. That's your output. So if I see it inside the parentheses here, that is your x. So I just need to find where x equals 3 is right here, and then find the output. When x is 3, we have a value of 9. Sorry about that. So here, we're going from x to find the f of x. On this next set, if f of x equals 9, what is x? Well, we kind of just did that. So let's talk about this one. If f of x, excuse me, sorry, equals 11, what is x? Because we're trying to find x, we have to recognize that this is the output, the y value. So I go to find where there's 11. Here it is right here. What is the x? I look across. This answer is x equals 4. All right. Now we're doing the same thing on the graph, but remember, on a graph we're looking for points, and we're looking for the x and y. And we have to read it accordingly. Like of f of 2, again, that 2 represents the x. Okay, so that means on the x-axis, I go to where there's a 2, which is right here, and then I find that point on the graph, which is right here. That point is 2 comma negative 2. So f of negative 2 equals, f of 2, excuse me, equals a negative 2. Okay, now the difference here is they want you to find the x when f of x equals 0. So this is when the y equals 0. So I go on the y-axis. There's the 0. Okay. So the x here is also 0, because that point is 0 comma 0. So you have to work forward and backwards. Okay. Now on 36 and 37, I'm going to look at 37. F of x equals x squared plus 7. if f of x equals 23, because they tell me what it equals, this is our output, okay? So this is our y. This is our result of the function. They want us to find x. So I have to take this and put this in place of the y, which is at f of x. So here, whenever they want you to find x, you need to write an equation. I'm going to abbreviate equation with EQ and solve for x. So when I write this, this is going to be 23 equals x squared plus 7. To solve for x here, you need to subtract the 7 on both sides. This is going to give me 16 equals x squared. And then because we have an exponent, you have to think of what value of x that I can square, raise to the power 2, multiply to itself. Gives me 16, because the inverse of squaring a number is taking the square root. And the square root of 16 is a positive or negative 4. And that's our answer. Okay. So if I was looking at the order pair, this would be 4 comma 23, or I can say negative 4 comma 23, because they both give me the same result. All right, so now we're getting into domain and range. What we have to remember on domain and range is domain is your x values, and when we read the domain on a graph, that means we're going left to right. I'm just gonna L to R. And then your range is your y values. And this, when I'm reading the graph, I'm going from bottom to top of the graph. Okay. Now, if this is mapping notation, so here if I want the domain, you're just gonna give me the set of numbers. So this would be 6, 7, and 8. Okay. For the range, our set would be our numbers -4, 3, comma 1, comma 5. Now, to determine it's a function, we can't have any repeating x's. Hopefully you remember that right here, when any time it splits, like it does here, this is saying 6 goes to 3 and 6 goes to 5. There's the repeating x's, so this is no, it's not a function. Okay, so check for your x's that they don't repeat. If they do repeat, it's not a function. So when we get to, I'm trying to think if it's, I want to go to 49 or 39. Well, I'll go to this next step. When you're doing it on a graph, you have to go to the left of the graph, the item, the bold line. So if I look, here's the left of it right here, but I need to look down and find the value on the x-axis. So right there, that's a -3. How far right does it go? Right here, look down, that goes to a +3. So to write this as an inequality, this would be a -3 is less than or equal to, because it's a solid line. Remember, if it's closed, it's equal to, less than or equal to x, which is less than or equal to the +3. Now we do the same thing for range, but we're looking bottom to top. The bottom of the graph happens right here, but now I look on the y-axis. That's at a -2. The top of the graph happens here, but I look on the y-axis, that's at 4. So it's a -2 is less than or equal to y, which is less than or equal to a +4. Is this a function? On a graph, you have to do the vertical line test, and you have to make sure it doesn't touch twice, which this does touch twice, so you have a repeating x. So this is a no. Sorry. Now, something with arrows. So I'm just going to talk about number 41 real quick, and then let you kind of practice. I'll probably stop the video after this and do the next step, because the next step's all linear equations. They kind of all go together. On 41 here, if I'm going to do the domain, our x values, I go far left, there it is, it's closed, but I have to look on the x-axis, that's at a -4. When I go all the way to the right of the graph, this has an arrow, okay? That arrow tells me it keeps going, so this will be showing infinity, even though, because I have to look at the actual x-axis. So this is going here, Okay, now, most students, when they're using inequality notation, are going to think, oh, this is a -4, which is less than or equal to x, which is less than or equal to infinity. But we don't use infinity in the inequality. We don't use, let me get this font. We don't use this part over here. So if -4 is less than to equal to x, and I see that this is going to keep going, some people just write this aspect of it, which is true, or I can rewrite it, switching the values, showing the x first. And when you do that, if I bring this x over to this side and bring it to that side, you would end up with, and I'm going to go above here, say -4 is less than or equal to x. Well, then that means x is greater than or equal to a -4. So it's starting at a -4 right here on the graph, but it keeps going to the right, so it keeps going to a positive direction. So it has to be x is greater than or equal to 4. So if you, I'm just saying, if they switched it, you have to, anytime I switch the terms around, notice that I switched the inequality. Okay. Now for the range, we're doing bottom to top. Well, the bottom here keeps going down. So if it's pointing down, this would be a negative infinity. This is the top of the graph, but I have to look where that is on the y-axis. That is at 3. So I'm at 3 to a negative infinity. Since it keeps pointing down, it starts at 3 and points down. If it's pointing down, that's less than. If it's pointing to up, that would be positive numbers. So down, we can see that these are all negative numbers. So if I wanted to go straight to one inequality, this would be y is less than or equal to 3. And is this a function? This answer was yes. It does pass the vertical line test. If I draw a vertical line there, or there, or there, it touches only once. So try to fix this, and that's our video to address that section. And then I'll have another video for, I guess, the remainder. Thanks.